Okay, today we are solving and graphing inequalities. Yesterday you learned about interval notation and graphing on a number line. Today we will be solving an inequality and then writing the interval in interval notation and graphing on a number line. So we're going to first talk about the golden rule of inequalities. When you are solving and you multiply or divide by a negative number, you must flip the inequality symbol. For example, if I have negative 3x is greater than or equal to 15, I'm going to follow the normal steps for solving an equation. I need to divide by the coefficient, which happens to be a negative number. So I'm going to divide both sides by negative 3. Now, when I write my answer, because I divided by a negative number, my inequality symbol has to flip the other direction. Don't change it. So if it is a or equal to, you must put that line beneath it. But I divided by a negative number, so now my inequality symbol flips and faces the other direction. Oops, sorry. I meant for that to be -5. Okay, so my answer is x is less than or equal to -5. So the steps we are going to follow are solve for the variable. Remember, these are going to be the same steps as solving for an equation. You're going to check the order. We always want to have variable, symbol, and then constant. So just like I wrote above, my variable was x, my symbol was less than or equal to, and my constant was -5. So just always check to make sure that you have x on the left and the constant on the right when you are done solving. Decide whether you're going to use an open circle or a closed circle for the number line. Draw the circle on the number line and then draw the arrow on the number line. So remember that the negative infinity goes on the left and positive infinity goes on the right. For an open interval, we will use an open circle. And you'll make sure you use parentheses when you do interval notation. This is going to be used for the greater than symbol and the less than symbol. These were on your notes yesterday. For a closed interval, this is going to be a filled in circle. We would use brackets, and the symbols for the inequality would be greater than or equal to and less than or equal to. So let's graph an inequality. So let's graph x is greater than 3. Okay, x is greater than 3. We're going to put 3 on the number line. Infinity goes on the right. And negative infinity goes on the left. I'm going to draw an open circle because I have a greater than symbol here. And x is greater than 3, so my arrow will point up the number line toward infinity. So when I write my interval notation, I will use parentheses, 3, and positive infinity parentheses. Let's graph one with a closed interval. So for this, I'll do x is less than or equal to 3. So I'll make the same number line. But this time I will draw a closed circle because I have less than or equal to, and my arrow will point down the number line. For the interval notation, negative infinity will be on the left because that's where my arrow is pointing, with 3 and a bracket. Okay, so now let's solve an inequality. So we will solve the inequality, graph the solution, and then we're going to write the solution using interval notation. So we have 6 times the difference of x and 1 is greater than 12. So I'm going to solve this the same way that I would solve if it had an equal sign. First thing I need to do is distribute. So multiply 6 times x and 6 times negative 1 is greater than 12. Add 6. So now I have 6x is greater than 18. Divide by 6. I'm not going to flip the inequality because I'm dividing by a positive number, so nothing changes there. My answer is x is greater than 3. So I have solved. Now I'm going to graph the solution. So I'm going to put 3 in the middle of my number line. And based on the symbol, I'm going to be using an open circle, and it will point up the number line toward positive infinity. I'm going to actually change this to green. And then now I need to write this using interval notation. So the 3 has an open circle, so that tells me to put a parentheses by the 3. And because my arrow is pointing up the number line, positive infinity with a parentheses goes on the right. Okay, number 2, x minus 3x minus 6 is greater than 4. So I don't have any parentheses, so I don't need to distribute, but I do have like terms. I have a 1x here and a negative 3x. So we add those together and I get negative 2x minus 6 is greater than 4. Add 6. I have negative 2x is greater than 10. And my last step is divide by negative 2. Now here, I'm going to apply the golden rule. So I need to flip this inequality to the other direction. So my solution is x is less than negative 5. So I'll put 5 on my number line. Sorry, negative 5. Now remember, when we have negative numbers, they're going to go down 5, 4, 3, 2 as we're going to the right, but the number is actually getting larger and going toward positive infinity. And as we go left, the number is getting lower, going toward negative infinity. When I plot this, I have a less than symbol, which tells me to use an open circle, and x is less than negative 5, so it's going to be all the numbers going down the number line toward negative infinity. Interval notation is going to be negative 5 on the right and negative infinity on the left. Number 3, here we have x on both sides of the inequality. So following the same steps as when we have an equal sign, we need to get x over to one side. There are no like terms I need to combine. Like terms have to be on the same side of the inequality to combine them. So I'm going to use inverse operations. I'm going to subtract 1x from both sides. So this becomes 5 minus 4x is less than or equal to 13. Subtract 5. Now I have negative 4x is less than or equal to 8. Divide by negative 4. Here again, I divided by a negative number. I have to flip my inequality. So this is going to become greater than or equal to. X is greater than or equal to negative 2. We're going to put it on the number line. Now this one will be a filled in circle, and x is greater than or equal to negative 2, so it's going to be pointing up the number line toward positive infinity. So my interval notation will be bracket, negative 2, infinity, parentheses. All right, one more example. This is a more complex inequality. Just make sure you're following the steps just like we learned when we were solving equations. The first thing we need to do is distribute. So remember, when you see a minus sign outside the parentheses, there is a 1 there, and we are going to distribute negative 1. So bring down 3, multiply negative 1 times 2x, negative 2x. Negative 1 times negative 7 is positive 7, is greater than or equal to 34 minus 6x. Now I need to look for like terms. Like terms have to be on the same side of the inequality. On the left, I have 3 and 7. So I'm going to make this 10 minus 2x is greater than or equal to 34 minus 6x. Okay, use inverse operations to get the variable to one side. So on the right, I'll add 6x, and on the left, I will add 6x. So now I have 10 plus 4x is greater than or equal to 34. Subtract 10, and I have 4x is greater than or equal to 24. Last step, divide by 4. This is a positive number, so I don't need to flip the inequality. It's going to stay greater than or equal to. So my answer is x is greater than or equal to 6. Okay, so now I graph it on the number line. This will be a closed circle. X is greater than or equal to 6, so I'm going to be going up the number line toward positive infinity. And my interval notation will be a bracket, 6, positive infinity, parentheses.